All right, guys, welcome to another episode of Cuda Education. We are back on the grind. So the thing that I've been working on and the powers that be need to address this is that compiling the anyhit shader with the .rahit extension, compiling it with the compile shaders.py script, or trying to compile it with that script doesn't work. Okay, so as you guys may have noticed, which other script was it? But anyway, I've been having problems getting the anyhit shader to basically update. So every time I would run the compile shader script, it would basically ignore this file because it's a different file extension. If you add the file extension in, it creates an error. It doesn't update the spare v file. And as you guys know, for the millionth time, the spare v file is the baseline file that is used by the GPU, by the driver, to actually follow the instructions of the shader that you put in here, right? So this is the shader. This generally lives on the GPU. It's GPU based instructions. You have to compile these shaders into spare v format or .spv file format, and then your script will be able to follow the instructions of your shader. However, if you're not able to do that, if you're not able to update the spare v file, then no matter what you do here, you're not gonna see any changes in your script. All right, and this has been a pain point for me for a little while now. So eventually I worked through it and I figured it out. But just know, guys, that this is an issue. All right, now, yeah, that's my contribution to this, is that this is an issue and you need to fix it. And it's not a simple fix. Okay, so I've since updated the script so that it will update when I change things in the .rahit file, okay, which is a GLSL shader. This also shows up in this guy right here. It also shows up in the ray tracing textures script. We do have another anyhit shader here. But I have other issues with this. Even if I update the spare v file associated with this one, like for whatever reason, the script just doesn't recognize the anyhit shader, right? I've tried to make sure the opaque and all that stuff is changed, but I have other issues with this. But yes, the anyhit shader does show up here. Okay, so I don't think what's another one? Yeah, so but anyway, for our purposes and for what we're trying to do, I'm now able to update the anyhit shader. Okay, so when you initially install these examples, these examples, there's a spare v file that is already generated by default, right? So it's not like when you install these examples, you won't be able to run the script. You will be able to run it because the spare v file was generated by default, right? It comes with sort of the example package. But my problem again is when I'm trying to update the anyhit shader and then I'm trying to generate a new spare v file, it doesn't, it doesn't update because the compile shaders.py script doesn't recognize this issue. So, I mean, this file extension. So, I'm not able to update and I can't basically make modifications to see the result. But now I can, all right? The added bonus is that when I'm compiling the shader, it just basically it it only compiles the files that have been changed, right? So if no files have been changed, it's not going to go through the whole list of all the shaders and all that stuff. So my compilations for shaders are going to be a lot quicker, which means my videos will be shorter, which means I will, you know, you won't have to suffer through long wait times every time I change the shader. So progress is beautiful, guys. Also need to know that Cuda Education is the best place on earth to learn computer graphics, especially as we talk about Vulkan computer graphics, right? The only thing I require is that you have a Windows-based machine with a Vulkan-capable GPU. That is also, for these examples, ray tracing capable, because all of these applications require ray tracing hardware. So you need to have a ray tracing capable GPU in order to run the ray tracing examples. If you have a Vulkan capable GPU, but it's not ray tracing, you'll be able to run the other examples, just not the ray tracing examples. Okay. All right. So let's take advantage of this progress. So, we have our ray tracing glTF algorithm, and when we run it, we get our glTF object, and as you guys know, it is a helmet. Okay. What I want to focus on this video is the goggles. Okay, so here is the goggles. We have a level of transparency, and we have things of that nature, right? And we could also see through it from this angle, all of that good stuff. Okay. All right. So the issue we had, let's just focus on this part right here. If the alpha value of the texture at the current UV coordinates is below a given threshold, we will ignore this intersection. That way, ray traversal will be stopped and the mesh shader will be invoked. So right now we have a threshold of 0.9, right? Let us change the threshold to 1.9. Okay. So we now have a threshold of 1.9, right? But let me compile. And notice that the compile takes it's a lot easier, quicker to do it, right? Okay, in this case, if we raise the threshold, I actually didn't try raising the threshold, but we basically get the same situation, okay? But let us now lower the threshold. So we're gonna do 0.1. So let us lower the threshold and let us see what we get. So basically, when we lower the threshold, we get opaque goggles, right? And this has to do with, of course, we lower the threshold. So if the alpha value of the texture at the current coordinates is below a given threshold, we'll ignore this intersection. So when we raise the threshold now, notice that we're starting to see through the goggles, right? And we could kind of peek through and see that stuff is being displayed. Okay, so stuff is being displayed slightly. And even when we go on the other side, we could see that stuff is being displayed. All right, so this has to do with, the point of this thing is that I just wanted to say that you know, these goggles, I guess, depending on how the ray hits and all that stuff, it has, you know, different parts of the goggle have different threshold, right? This language is just a little bit confusing, honestly. If the alpha value of the texture at the current is below a given threshold, we'll ignore the intersection, right? So let us do 2.55, right? We got to compile our shaders, guys. We got to compile our shaders. So let's run it and we'll see what we get. Okay, so now we're getting closer to what we know already, right? So I think that move was a little bit too, it was too dramatic, right? So we were at 1.5 before. So let's do 1. Let's just reset our mind. So we were back at this. Right? We were back at this. Right? This is what we were at. All right, so let's just change it now to 1.8. All right. Got to recompile the shader. All right. Okay, we're starting to see a little bit more clarity, but notice that it's still a big jump, right? So we're right at that cusp of, you know, so let's do 1.7, right? So basically, I just wanted to show that this piece right here affects you know, so now we get a little bit different, right? So that's it, guys. And then if we just take this out, I have to recompile. I guess I should start doing Control F5 now that we're so fast with everything. You know, so we're not ignoring intersections now, right? So we basically just apply this. It's an opaque situation, right? Because we're not ignoring the intersection, right? So it's a beautiful thing, guys. We're now able to mess around with the anyhit shader, which is a good thing because I didn't want to leave this project without we're back to normal. I didn't want to leave this project without now the thing, I didn't even try like a really big number, but I don't think it changes anything. Actually, it makes it a lot clearer, a little bit, I think, right? Let's compare it to what I had before. Is it clearer? I don't know. No, I don't think so. I think it's the same. All right, let's just go crazy on this. See if that changes anything. All right, so now we kind of, I don't think it changes anything. So there might be other things at play. It doesn't change anything. I think it's the same. It's the same situation, right? It doesn't change anything. So now we have to investigate what this color.a is doing. Yeah, it doesn't change anything. All right, that's all right. So we'll just leave it. We'll go back to default, right? Make sure my thing is running fine. All right. All right, so we're back to normal. All right, so we have, you know, we have this color variable that deals with the texture, and then we basically test for a threshold, right? I'll get into this more in another video. Notice, guy, that this is the anyhit shader. If the alpha value of the texture at the current is below a given threshold, we'll ignore this intersection. That way the ray traverse will be stopped and the mesh shader will be invoked, right? But yeah, I mean, that's all I wanted to show at this point. So we are able, with any texture, we are able to test the alpha value and then do instructions. I want to see what this does. So let us change the, so instead of it being greater than, we do less than. And let's see what happens here. We get this, but so he basically inverts what was around the thing is now clear. So right here around it is clear, and then this stuff is, you know, so this is, I think this is part of the jitter business, right? So if we do 1, 5, you know, that'll be your homework for you guys. Why when I change this to lesser than, we get a different thing, right? This is all math. That's why it's important to really have an appreciation for math, because programming, a lot of programming is basically math. All right, it doesn't. Anyway, let's make sure I get back to normal. I got to recompile. Well, I don't even know. Did I compile for this guy? Let me just make sure I actually did it properly. Let me make sure I did it properly. All right, it doesn't change anything, but okay, so let's go back, and then we will. All right, so we're back to normal, guys. All right, so we are back to normal. So yes, guys, we are able to modify the anyhit shader. Right now, I don't believe we have anything else that we need to unpack at this moment. Let me see if I change this, what happens. That's a discussion for a different day. All right, guys, so now we know how to do alpha testing on a texture and how we simulate transparency in the anyhit shader, right? So again, basically when the ray comes through the scene, we have to decide if we intersect something, are we going to respect that we intersected something, or continue traversing the scene. In the case of goggles, we continue to traverse the scene and record and pick up what happens behind the glass, right? I guess for other materials that won't be the case, and that's why we actually see the helmets, right? And we see the straps and everything around it, right? And the wood and all that stuff. But for in the case of goggles, we hit the glass of the goggles, but we still continue and proceed through it. Anyway, guys, this is Cuda Education, the world's greatest tutorial on computer graphics. Absolute greatest. There is no place else in the world that is greater. Again, if you want to learn this stuff, you have to have code running on your machine, right? Tutorial number 1 is installing the Vulkan API. Tutorial number 13 is installing these examples, right? I assume a Windows-based machine, a GPU that is Vulkan capable and ray tracing capable. For NVIDIA, it's RTX cards and above. For the other vendors, I have no idea. Thank you for watching. Like, subscribe, tell your friends. You know, you guys work on this stuff as a group. Learn something. You know, even with this anyhit shader thing, I had to spend some time and figure out how to get this shader compiled, right? Because the default compile shaders.py does not work for the .rahit files. Thank you for watching. Have a great day.